all, welcome to SAIMEDHA KOTI, Hyderabad. Now, we'll try to observe the solutions of signals and systems given in ISRO paper 2025. So, here are the signals and systems questions. What is the first question? In this question, he is asking what is the Nyquist rate for a continuous time signal x of t is equal to 5 cos 100 pi t plus 2 sin 200 pi t. Now he is asking us to find out the Nyquist rate. First of all, before going to solve this problem, what is the principle involved in calculating the Nyquist rate? In order to calculate the Nyquist rate, what you have to do is, in the given signal, you try to get the highest frequency component. What I am saying, you try to get the highest frequency component, and after getting that, twice the highest frequency component gives you Nyquist rate. Now, if you observe our signal x of t, here there are two frequencies. How many frequencies? Two frequencies. First frequency is 100 pi and the second frequency is 200 pi. So, what is the maximum frequency? Maximum frequency I am denoting by omega m. Omega m is among 100 pi and 200 pi, the highest frequency is 200 pi, isn't it? 200 pi. But omega m, this is omega m, but the answer is given in terms of hertz. So, we must get the frequency in terms of f. I can write this as 2 pi fm is equal to 200 pi, I can write this as 2 pi into 100. Or what is the value of fm now? The value of fm is 100 hertz. 100 hertz. Now the Nyquist rate, if you want, fs, I am denoting by Nyquist rate by fs, is given as 2 fm. 2 fm, that is 2 multiplied with 100. So, which is nothing but 200 hertz. 200 hertz. So, the Nyquist rate for the given problem or the given continuous time signal is 200 hertz. So, you can select option 2 as the answer. Now, let us look at the next question. Yes, this is the next question. In this question, what did he say? Which of the three signals given below is periodic? Periodic signal we have to choose. x1 of t he has given, and first one is continuous time signal, second one is a discrete time signal he has given, and the third one is a discrete time signal, but he mentioned here as x3 of t. There is a printing mistake in the problem given. This must be x3 of n. x3 of n. Right. Now, what are the options? So, options are given like this. We will do one thing. We will try to verify which of the following signal is periodic. The first one, if you verify, 2 e power j into t plus pi by 4 u of t. See, this is not a periodic signal. This is not a periodic signal because this signal, this e power j into t plus pi by 4, basically it is a complex exponential. The name for this signal is complex exponential. Complex exponential signal. It is periodic. Complex exponential in continuous time is periodic, but here multiplied with u of t is there. Multiplied with u of t means the signal exists from 0 to infinite only. But for a signal to be periodic, the starting point must be minus infinite and ending point must be plus infinite. So, this particular signal starts at 0 and ends at infinite. So, this cannot be a periodic signal. So, x1 of t is eliminated. Now, let us try to verify the second signal, x2 of n. x2 of n is u of n plus u of minus n, right? So, in order to verify the periodicity of the second signal, what we will do is, we will try to draw the shape of the signal. We will try to draw the shape of the signal. U of n. How to draw U of n? U of n is discrete time unit step. U of n is discrete time unit step, which looks like this, isn't it? This is discrete time unit step. Its value is 1 for n greater than or equal to 0, and it is 0 for n less than 0. Now to this U of n, you calculate U of minus n. U of minus n is the time reversed version of U of n. Take the mirror image along vertical axis for this U of n. So this signal will look like this. U of minus n will look like this. So both the signals are ready. U of n and U of minus n are ready. Now try to add the signals. If you add, what is the value at 0? At 0, this signal value is 1, this signal value is 1. 1 plus 1 is 2. Again at 1, this signal value is 1. Here nothing is mentioned, means you can take the absent sample as 0. So 1 plus 0, 1, and 2 also it is 1, and at 3 also it is 1, and so on. Now at minus 1, this value is 1 and this value is 0. Like this. This is the shape of the signal U of n plus U of minus n, which is our x2 of n. x2 of n. Now if you observe, by looking at the shape of the signal, we can say that this is an aperiodic signal. Periodic signal means here the signal must repeat at regular intervals of time. But here the sample at 0, which is the value 2, it is not repeating. It is not repeating means the signal cannot be a periodic signal. So option 2 is also eliminated, right? Now option 3 can be the answer, and let us verify by drawing the signal. And here one more important point is, here in the question he has mentioned something like k is equal to minus x2 plus x. So there might be a printing mistake. Basically this is k is equal to minus infinite to plus infinite. See, why I am saying with this much confidence means this question is directly extracted from the standard books of signals and systems by Oppenheim, and the question number for this one is 1.6 in the first unit. If you look at the signals and systems by Oppenheim, in the textbook, in the question number 1.6, this question was given. So this is minus infinite to plus infinite, and if you try to draw the shape of this signal, definitely this is a periodic signal. Now let us verify also. What is that signal? X of n is equal to summation k varying from minus infinite to infinite del of n minus 4k minus del of n minus 1 minus 4k. Now how to draw this signal? This signal can be drawn by giving different values of k, and the values of k must be integers, right? What happens if I substitute k is equal to 0? If I substitute k is equal to 0, what is that I am going to get? K is equal to 0, you substitute del n minus del n minus 1. So this is del n minus del n minus 1. Minus del n minus 1 means it will look like this, right? Now substitute k is equal to 1. If you substitute k is equal to 1, what is that you are going to get? Del of n minus 4 minus del of n minus 5. So del of n minus 4 is the delayed version of del of n by 4 units minus del of n minus 5. Minus del of n minus 5 means it will look like this. So this is for k is equal to 0, and this is for k is equal to 1. Now what happens if I substitute k is equal to minus 1? If I substitute k is equal to minus 1 here, this becomes del of n plus 4, which looks like this, minus del of n del of n plus 4 minus del of n plus 3, this one, and so on and so on. This is for k is equal to minus 1. Now observe the periodicity. This is our signal x of n. Shape at 0 is repeating at 4, or shape at 1 is repeating at 5, shape at minus 3 is repeating at 1, or shape at minus 4 is repeating at 0. So from the shape of the signal, I can say that the given signal is periodic with period of n is equal to 4. N is equal to 4. So among the options, you can select x3 of not t. Basically this must be x3 of n. Printing mistake is given in the question paper. So x3 of n becomes the answer. X3 of n becomes the answer, right? In this way, this problem can be solved. Let us look at the next question. The signal x of t is equal to sine 100 pi t by pi t is, he has given 4 options: time limited and band limited, time limited and but not band limited, time limited but not time limited but band limited, neither time limited nor band limited. So here first of all, first doubt is here band means frequency. Band means here frequency. Frequency. Band means frequency, right? And here how to verify? How to verify this one? See, one important point you must know before solving this problem, that here that point is a signal. Suppose if you have a signal, cannot be time limited and band limited. A signal cannot be time limited and band limited. Band means frequency. What I am saying, a signal cannot be time limited and band limited. Suppose if the signal is limited in time, then it will be unlimited in band, and if the signal is unlimited in time, then it will be limited in band. For example, del of t is there. What is the Fourier transform of del of t? It is 1. So del of t, the signal looks like this, continuous time impulse signal, and whose Fourier transform is 1. 1 means this kind of shape, constant DC. If you observe, this signal is limited in time, but this is unlimited in frequency, that is band. Yes or no? Suppose if I take the signal 1, what is the Fourier transform? 2 pi into del of omega. Now if I try to draw this signal, this is unlimited in time but limited in band. Limited in band. So this statement, a signal cannot be time limited and band limited. And one more point is, a signal can be time unlimited, band unlimited. Time unlimited, band unlimited. A signal can be time unlimited, time unlimited and band unlimited. Time unlimited and band unlimited. For example, if I take the signal e power minus at u of t for a greater than 0, its Fourier transform is 1 by a plus j omega, right? And what is the shape of e power minus at of t? This is the shape, unlimited in time. And if I take the magnitude, of the Fourier transform, so this one, this kind of shape you will get. So what I can say, this is time unlimited, this is band unlimited also. So time unlimited, band unlimited. Having known this, let us come to our problem. So a signal x of t is equal to sine 100 pi t by pi t is. See, for this we have to remember one important basic Fourier transform pair, that is, if I have a signal of the form something called sine at by pi t, its Fourier transform would be a rectangular pulse varying from minus a to a in frequency domain, or I can write this as rect of omega by 2a, right? Now the given signal sine 100 pi t by pi t. What could be the Fourier transform? The Fourier transform could be simply a rectangular pulse varying from minus 100 pi to 100 pi. Right? Now, this is of the form sine at by pi t. If you try to draw the shape, it takes the form like this. The shape will come something like this. Right? So this is the shape. This is unlimited in time but limited in, this is unlimited in time but limited in frequency or band. So what could be the answer? Unlimited in time and unlimited in time but limited in band. That must be the answer. Time unlimited, not time limited but band limited. Option 3 becomes the answer. Hope you understood this question. Let us look at the next question. Which of the following systems is not causal? And he has given 4 options. First of all, for causality of LTI systems, and in particular discrete time LTI systems, this condition must be satisfied. H of n must be 0 for n less than 0. This is a condition for a discrete time LTI system to be causal. So if you can draw the shapes of the impulse response, yes, you can find out which of these LTI systems is not causal. First one, del of n. Del of n means what is the shape? Del of n means this is only the shape, right? This is the shape. Now, does your h of n is 0 for n less than 0? Here, by looking at this impulse response, clearly I can say h of n is 0 for n less than 0. So, this corresponds to a causal system. So, this is not the answer. Next, h of n is equal to u of n. And do you remember the shape of u of n? Discrete time unit step signal. This is h of n is u of n. And clearly here also h of n is 0 for n less than 0, which confirms that this corresponds to a causal system. This is also causal. So this is not the answer because it's asking for not causal. Del of n plus del of n plus 1. So del of n is this one. Discrete time, this is del of n, discrete time unit impulse, plus del of n plus 1. Del of n plus 1 is advanced version of del of n by 1 unit. So this is the impulse response. Now if you observe, h of n is not equal to 0 for n less than 0 because we have one samplet minus 1 also. And if you observe so this is the answer, and if you observe this signal, h of n is equal to 0.5 whole power n u of n. What could be the shape? U of n means signal starts from 0. Now give different values of n. So if I substitute n is equal to 0, 0.5 to the power 0 is 1. If I substitute n is equal to 1, 0.5, n is equal to 2, 0.25, like this. Here also h of n is 0 for n less than 0. So this is not causal. So option 3 becomes the answer. Among the given options, option 3 becomes the answer. Yes. Now let us look at the next question. If a discrete time LTI system has a frequency response h of e power j omega is equal to 1 by 1 minus 0.5 e power minus j omega, what is its impulse response h of n? He gave the 4 options. First of all, before solving this problem, you must know what is the relationship between impulse response and frequency response of a discrete time LTI system. See, for a discrete time LTI system, if you have the impulse response h of n, for a discrete time LTI system, if you have the impulse response h of n, and if you are going to calculate the discrete time Fourier transform of this impulse response, we are going to get the frequency response. DTFT of discrete time Fourier transform of impulse response gives frequency response. And please remember that the frequency response tells us the filtering capability of the system. From the frequency response, we can know the filtering capability of the system. Frequency response tells us the filtering capability of the system. Now, in the given problem, he has given the frequency response and is asking us to find out the impulse response. Means you have to take the inverse discrete time Fourier transform. For this, you must use one standard DTFT pair, that is discrete time Fourier transform pair, that is a power n u of n for mod a less than 1 forms a DTFT pair with 1 by 1 minus a e power minus j omega. A power n u of n forms a DTFT pair with 1 by 1 minus a e power minus j omega. This is standard DTFT pair, you have to remember. Now, what is the frequency response he gave? 1 by 1 minus 0.5 e power minus j omega. Do one thing, simply calculate the inverse or use this pair, transform pair. So, what is the in place of a? 0.5 whole power n u of n. So, this will be the impulse response. So, this is the frequency response, this is the impulse response. So, search for this option. Option 1 gives the answer, 0.5 whole power n u of n. In this way, you can solve this particular problem. Let us look at the next question. The Z transform of a signal x of n is equal to del of n minus k, where k is a positive integer is. See, in order to get the solution for this problem, you can use the time shifting property of Z transform, which says that if the signal x of n forms a Z transform pair with x of z, here I am not mentioning the ROC, x of n forms a Z transform pair with x of z, then x of n minus k forms a Z transform pair with z power minus k into x of z, or yes, x of n, x of z, x of n minus k forms a Z transform pair with z power minus k into x of z. This property we can use, according to which, what is the Z transform for del of n? Del of n Z transform is 1. Del of n Z transform of discrete time unit impulse is 1. Now he is asking for del of n minus k. Simply apply the property, and he said that k is a positive integer, right? So x of n, x of z, x of n minus k, z power minus k multiplied with x of z is anyway 1. So this must be your answer, z power minus k. So among the options you can select option 2 as the answer. Very simple question, very simple question, right? This is the next question. A discrete time LTI system has impulse response h of n, which is given by del of n plus del of n minus 1, and he is asking what is its output y of n for an input x of n is equal to u of n? Very simple question. Here for a LTI system, that is discrete time LTI system, this information is given. This information, what is that? The information is impulse response is h of n is equal to del of n plus del of n minus 1. Now he is asking us to calculate the output for the input x of n is equal to u of n. U of n. Now this is output y of n, right? And means he is asking us to see input is u of n means output, whatever the output you are going to get is basically the step response. So here input is there, impulse response is there. So for a LTI system, if input and impulse response are there, output is simply the convolution of input and impulse response. Output is simply the convolution of input and impulse response, or y of n is u of n convolved with h of n. H of n is del of n plus del of n minus 1. Now convolution of a signal with an impulse signal gives the same signal, and you can use a distributive property, plus convolution of a signal with a shifted impulse, simply shift the signal. So the answer would be u of n plus u of n minus 1, and among the options you can select option 1 as the answer. Option 1 will become the answer. Yes, this is the next question given from signals and systems, and the question he said, let x of t is equal to rect of t by 2, okay, where rect of t by 2 is a rectangular pulse of width t centered at t is equal to 0, that is x of t is equal to 1 for mod t less than 1 and 0 otherwise, okay. What is the Fourier transform x of omega of x of t? So he is asking us to find out the Fourier transform of rect of t by 2. Rect of t by 2. First of all, look here. For solving this problem, let us see what is the general form of standard rectangular pulse. Standard rectangular pulse is this one. See, this rectangular pulse can be represented as, what is the amplitude? A. What is the name we are saying? Rectangular, in short rect. What is the independent variable? T. And what is the overall duration for which this pulse is existing? Minus t by 2 to t by 2 means t. So the representation of this rectangular pulse can be given like this: A rect of t by capital T, right? Now A rect of t by capital T. Suppose if I ask you what is the shape of rect t? What is the shape of rect t? Rect of t means, rect means rectangular pulse. What is the amplitude? 1. Independent variable is t. And what is the overall pulse duration? 1. Means from minus 1 by 2 to 1 by 2. This is rect t. Rect t. Fine. Now come back to Fourier transform. If you come back to Fourier transform, A rect of t by capital T, A rect of t by capital T forms a Fourier transform pair with, in terms of sinc he has given, no? So AT sinc of omega t by 2 pi. AT sinc of omega t by 2 pi. This you have to remember. A rect of t by capital T forms a Fourier transform pair with what? AT sinc of omega t by 2 pi. From which, if I want the Fourier transform for rect t, rect t means what should I do? Simply substitute A is equal to 1, capital A is equal to 1, capital T is equal to 1. So it is sinc of omega by 2 pi, isn't it? Sinc of omega by 2 pi. Hope you are getting, right? Now let us try to understand what is the scaling property of Fourier transform. Scaling property of Fourier transform says that if the signal x of t forms a Fourier transform pair with x of omega, then x of at forms a Fourier transform pair with 1 by mod a x of omega by a. This is the time scaling property of Fourier transform. X of t, x of omega, x of at forms a Fourier transform pair with 1 by mod a x of omega by a. The principle involved in scaling is only one thing, that you identify the scaling factor first, and after that in your Fourier transform, wherever you have omega, replace with omega by a, right? So this is the rectitive Fourier transform is sinc of omega by 2 pi. Now what could be the Fourier transform of rect of t by 2? Rect of t by 2. So what is the scaling factor? We identify the scaling factor 1 by 2. So what we have to do? In your original Fourier transform, that is here, wherever your omega, replace with omega by a, means omega by 1 by 2. So 2 omega. So here wherever your omega, replace with the 2 omega. So according to the property 1 by a will come. 1 by a means 1 by 1 by 2, 2 sinc of. So wherever your omega, replace with the, observe here, 2 omega. 2 omega by 2 pi. Or this is 2 sinc of omega by pi. So this must be the Fourier transform of rect of t by 2. Rect of t by 2. So let us search for the options. 2 sinc of omega by 2 sinc of omega by pi must be there. So 2 sinc of omega by pi is not there. To our surprise, 2 sinc of omega by pi is not there. So what could be the answer now? What could be the answer? Answer is not there, answer is there. But here what happens, you know, sinc of t is sine, basically sinc of t is sine pi t by pi t. Pi t by pi t, right? Some textbooks take sinc t as sin t by t only. Sin t by t means he might have, okay, he might have taken this definition instead of this. We went by this one, but he is going by this one, right? So we have to get in this form. So what I can do is, look here, according to his notation, a rect of t by capital T must be at sinc of omega t by 2 only. At sinc of omega t by 2 only, according to his form. Basically most of the time will be going with this one only, but the answer is not matching, means sinc t definition he has taken this one, not this. So we must go according to him. So a rect of t by capital T, at sinc of omega t by 2. So from this, what is rect t? Rect t is, you know, a is 1, t is 1. So sinc of omega by 2. Now rect of t by 2 I want. Rect of t by 2 means use the scaling property, identify the scaling factor, that is 1 by 2, and in the Fourier transform wherever your omega, replace with omega by a, omega by 1 by 2, which is nothing but 2 omega. So 1 by a means 2 sinc of wherever your omega, replace with 2 omega. So 2 omega by 2. This is 2 sinc of omega. So this must be definitely there. 2 sinc of omega, right? Yes. So you may get one doubt, sir, is this a wrong answer? No, it is not at all a wrong answer. It is the correct answer when you are going to take sinc t as sin pi t by pi t. Now some textbooks refer sinc t as this definition and some textbooks refer sinc t as this definition. So both are allowed. So most of the time we'll be following this one, but he followed this one, with which answer will change. Answer is 2 sinc of omega. So option 1 becomes the answer. In this way, the questions of signals and systems can be solved from the ISRO paper.